So the Mad Scientist mug monitor is coming on quite well. This is the bottom of the box. Everything's been mounted in that now. There's a few wires still connect up. And then all this lot needs to mount on the lid, which is being spray painted down in the garage. And the lid of the box has been spray painted several times. Probably had enough coats now, but I might do one more. That piece of tape you can just about see there is where the display is going to be, so that hopefully will pull off. So the Mad Scientist mug monitor is coming on. We've still got the temporary dummy temperature sensor on there because they haven't arrived yet. Unfortunately I had some problems with the case. The idea was this clear plastic case. I was going to spray paint inside and leave a window for the display. Unfortunately the masking I did using PVC tape, the paint managed to get under it at the edges and across the middle there where I left a tab to pull the tape up, and also it crept through the holes for the potentiometers and did the same sort of thing, which has left marks on the front, but never mind. So we turn it on. Fortunately the hole is just about big enough so you can see the bits of the display that we're using. So the mug monitor is now back together with a properly working temperature sensor. You can read about that or listen about that fiasco in another video. And it's all back together and working properly. The temperature now responds as it should do. You can see the room temperature is about 20. The last job is to fix these Velcro straps on that are going to go around a mug. So these are like cable tidy things, and I'm going to join two of them together to make them long enough. And to do that I need to get the sewing machine out, the very modern sewing machine. So here we have it, the 90-year-old Singer sewing machine. They don't make them like this anymore. And people think that these intricate works of art are going to be worth hundreds of pounds as antiques. But in fact they were made in such huge numbers, like millions, that they're only probably worth about 20 to 50 pounds even in working condition. This one's quite old, as I said, it's about 90 years old, and it has this, what they call a vibrating shuttle underneath, as you can see there. These covers are usually closed when you're sewing, in place of the more modern systems which would have bobbins. These are bobbins out of a more modern machine underneath there instead of that shuttle arrangement. And this came from a great uncle when they were moving house and wanted to clear out, and it had a horrible motor assembly with it, a sort of a third-party motor that another manufacturer had made, and it looked like such a death trap, sort of 1930s wiring, that it went in the bin unfortunately, so we've got to revert to the manual handle here. The machine comes with this intricate set of attachments for doing different things, whereas on a modern machine you probably just press a button to do them. Some of them look really like something you'd find in the dentist maybe, and this booklet tells you all about each of the attachments. So what we're going to do is sew these two Velcro straps together to make them long enough and sew that bit back on that's fallen off. And then we'll be ready to sew it manually by hand onto the temperature sensor, which is over here. So just a word of warning before you use your mum's brand new sewing machine on a mad science project. These old sewing machines are perfect if you want to sew things like Velcro or leather or anything that's quite difficult to sew through, because they're basically built like a tank. If I show you inside it, it's pretty simple, and they're great big lumps of metal everywhere. Whereas a modern one, it's probably got little plastic gears and little motors, and they all like catch fire and break when you try and do something like that. So anyway, the little pocket's done for the temperature sensor and the two bits of Velcro are joined together. So now we're ready for the final test. Well, I've had a few more unexpected issues to sort out. Firstly, the temperature reading was still fluctuating quite a lot. So I decided to put an averaging time in there of a second, so it averages the measured temperature of a second before it displays it and uses it. Secondly, I was still getting weird temperature readings then when I had the volume turned up, but it was fine with the volume turned down. And this turned out to be a problem when you read different analog inputs, because it's only got actually one circuit that's switching between the inputs. The first reading you take after you've changed inputs is unreliable, so you have to take a dummy reading. So that solved that. And thirdly, I decided I didn't want the alarm to go off until the set point had first been exceeded and then dropped back below. So at the moment you can see the alarm isn't sounding with 27 degrees, even though the set point's at 32, because the temperature's firstly got to rise above 32 before the alarm will trigger when it drops back below. So we're now going to finish boiling the kettle, pour the water in and see what happens. So here goes the water, and we should see the temperature go up. If it doesn't, I'll be really annoyed because I've shot this video so many times with different faults. Try to match it around the bend. Oh dear, it's stuck at 27. Hopefully it will go up. Here we go. Temperature's coming up. I said it took a while to react because of all the Velcro and stuff around the temperature sensor. So now the temperature's rising. And the alarm won't sound until it's gone above 32 and then back down again, which could take a while. So I'm going to switch over to a time-lapse video for that. Well, you probably saw my attempts to speed things up there by pouring cold water in and raising the set point. But the point is that did actually do what I wanted to, so that's great. Thanks for watching, and hope you're inspired to build your own crazy gadgets.